Hello all, welcome to Excel Academy. Yesterday I couldn't make a video for some reason, but today I'm back with this video. So this is with respect to DSP. Circuits we'll be doing it soon, and controls also I'll do it today. Okay, circuits I'll be doing it without fail. Actually there was a delay in circuits video, so you have to adjust that. I'll do it for sure. Okay, because now circuits and the DSPs are really important now because they start from the circuits as well as DSP concept. That is why I will do circuits and DSP without fail, right? So now this is what is one video with respect to DSP. So my question states that the two sequence x1 of n and x2 of n are given as follows. That is, my x1 of n is equal to 2 1 2 1 and x2 of n is 1 2 3 4. So find out the sequence x3 of m, which is equal to circular convolution of two sequence x3 of m is equal to x1 of n circular convolution. This n with a bracket as circular convolution, that is x2 of m. So now here this question is asked in 98 September 98 is, it has been from the year 1997, right? This DSP, control system, networks and signals all were established during that period only, 1997 and 8. Till now it is present, right? Till now it is present. They are good old subjects. They are very good old subjects which has been introduced in the year, in that particular year itself. Fine. And then this is June 12. That is June 2012. That is 8 marks, right? And you might feel this is asked for in the year 98 and in the year 12 and it is for marks 8. But no, it has been asked for you people also. How? I'll tell you, just a minute. Just give me some time. See, this is asked you to find out concentric circle method. That is a circular convolution method. Circular convolution method is only a concentric circle method, right? Yes, that is what is asked for. You see here, and in the other question paper. In the other question paper, see, this is circular convolution using DFT and IDFT method. This is DFT and IDFT method. This is not a circular convolution method. It is asked you to compute circular convolution, but it is asked you to find out using DFT and IDFT. DFT and IDFT in the sense you have to, what I can say, make use of the DFT and IDFT methodology. So this is not the one. Just a minute. Let me just check. Yes, I guess this particular question, that is circular convolution of what I can say, that is here x1 of n is equal to, that is 1 2 3 minus 1 and x2 of n 4 3 2 2. So this is using time domain formula. So time domain formula in the sense this one, that formula whatever is present for you. So by using that formula you are going to determine the circular convolution. So this is also one question, students. And next one, just a minute. I'll just check it out. Just a minute, wait for a second. Yes. So this particular question, what I told you, it is DFT and IDFT method only to solve. So I have to solve it using DFT and IDFT method. That is what is supposed to do is this. I have already taught you, but let me reteach it. I guess you know what is DFT and IDFT methodology, how to apply DFT and IDFT methodology. So the same way you are going to apply, but there are two sequences. That is, one is x1 of n and x2 of n. That one I'll tell you how to handle with two sequences, but the methodology is the same. DFT methodology the same formula, IDFT methodology the same formula. So why I just discussed with respect to this is because it's asking you circular convolution question. I'm just showcasing you, right? I showcase circular convolution question. See, this was one circular convolution question, that is 5-point circular convolution question. He is asking you to find out using concentric circle method. Concentric circle method is now that we discussed, and this particular is by using DFT and IDFT method. So now as we're dealing with question on circular convolution, we need to know how many types are present in circular convolution. That is, one is concentric circle methodology, and what I can say the one is which is equal to what I can say the DFT and IDFT methodology, right? Here he has asked you to find out the circular convolution using time domain and frequency domain. That is, you need to solve it using the time domain formula, and you are going to verify the result using frequency domain approach. This also we are going to do. And the last question paper, in the last question paper is asked to find out the DFT and IDFT method only using DFT and IDFT method, and that is these two are the sequences, right? Why we are discussing with respect to circular convolution now? Actually, circular convolution has to be discussed after we do the derivation of circular convolution. But why now we are discussing this? Because I have taken a concept which I said as 4-point DFT, right? I am doing all the problems with respect to 4-point DFT. So that is why I am considering a topic called 4-point DFT, and under 4-point DFT whatever the questions that comes I am going to do irrespective of the methodologies, right? We have discussed a question from 4-point DFT using what? One is formula method. I'll just write FM, that is formula method, and second one we discussed about MM, that is matrix method. I'm writing in a short form, I guess you understand. So this is formula, F for formula, M for matrix, and this to M for method, right? And now we are discussing with respect to circular convolution, the 4-point DFT using circular convolution, right? In circular convolution you get what I can say the uh, two, that is what I can say sequences. Two sequences you get, the two 4-point DFT sequences, and for that you are going to do it using one is concentric circle method and one is DFT IDFT method, right? We are going to discuss that, and by discussing the both we are going to end the topic on 4-point DFT, right? Why? Because if I go for one particular method and take all point DFT, it is like somewhat you might get confused. So I just thought of taking 1-point DFT, that is 1 point in the sense I am going to take any one of the point DFT. So for you people, that is your 4-point and 8-point is really important, right? 4-point and 8-point will plays your major role. 5-point, 6-point, 7-point is not of that importance. Actually, sometimes he might ask, but your 4-point DFT is really important and your 8-point DFT questions are really important. That is why I am considering a topic called 4-point DFT, and I make sure that on the topic called 4-point DFT we learn all the methodologies that you can apply for 4-point DFTs, right? So that is finding out the 4-point DFT using a matrix method or using a formula method or using 4-point IDFT using a 4-point IDFT, what I can say using a formula method, or what I can say using your this thing which is that matrix method, or you to having a two sequence of 4-point DFTs and finding out the resultant circular convolution using what I can say your matrix method, this thing concentric circle method or a DFT IDFT method. So that is what is my idea. My basic ideology is to clear all the methodologies with respect to 4-point DFT, right? That actually is a circular convolution method. This formula, whatever you see here for circular convolution in the question, so that formula we have to first do it. We have to first do it as a derivation and then come back. But why I am doing it now is because as that question is related to 4-point DFT, so I am considering a base called as 4-point DFT, and according to that I am going. That's it. I'll just tell you that formula. So that formula we are going to solve it when we go to properties of DFT, right? When we come under the topic called as properties of DFT, we are going to learn all the what I can say the properties of DFT, right? I guess in your syllabus, just a minute students, let me take some time. I'll open your syllabus. So, and my cell phone, and I'll tell you just a minute. Wait a second. According to a syllabus, you have circular convolution. So we'll learn there. Okay, we learn the derivation of circular convolution there. Now try to learn the formula, right? Now try to learn the formula. You can learn for circular convolution derivation and after the problem. But in the case of circular convolution, you have both 4-point DFT as well as 8-point DFT problems in circular convolution. This x1 of n and x2 of n, you might get it as 8-point DFT or 4-point DFT. That is why now I got a question on 4-point DFT and I am going to do. Here you have two 4-point DFT sequence. That one you need to understand. So now I'll make this little bit shorter because I have to start writing this. Just a minute students. I'll Okay. Okay. So now I'll make this a shorter, still more shorter. So I'll just tell you the question by words, and I'll just start it now. So how I am teaching you the subjects and circuits and controllers, I'm trying to take all the important questions and I'm trying to teach you, right? It is not with respect to that you have to study important questions and just pass your exams. No, for circuits and controls is not like your DSP. Your DSP is quite different, completely different from circuits and controls, because your circuit and controls, you have to work more and more circuit. You have to work it on more and more circuits in the circuits and controls, and in the circuit you might see different things. You might not see the same thing. When you apply the KVL, there might be some difference with respect to KVL. For example, when you apply KVL, you get a current I1. He'll only give the current I1, so no need of applying KVL to that first mesh. Or you might get different things in KVL. You won't get it directly. The circuit might be quite complex. You have to see through the circuit. You have to apply according to KVL, according to the circuit. So the KVL methodology is the same, but the circuit might be complex. According to the circuit, you apply the KVL or KCL with respect to nodal analysis, right? That is why this DSP, in the DSP, what happens is that you have to just understand how the procedure goes on. So you have a procedure called what I can say, the formula method. So you need to understand the two formula and how to work on with respect to that formula, right? If you learn one or two questions, the other question will be really easier. You might get a question like this, like I'm sorry, you might get a question like this. What is this question? This question is telling you that is 0 is lesser than or equal to n lesser than or equal to 2. What that I'm sorry, what does that mean? That means that what is supposed to do is you are going to just apply the values of n. Just apply the values of n and then get the resultant. In cos pi by 2, what did we do? In cos, that question we did know. Which question? That is your cos question. I will just open that question. So we discussed one question with respect to the, yeah, this one. That is, I'll showcase the question. That is cos. Where is that question? Just a minute, I'll open the question. It is cos n pi by 4. What did we do? We just substituted the value of n in the case of cos n pi by 4. Like that here you have to do, and you get a value, and for that you are going to do. Like that the question might come, but the process is same. But the process, if you understand, you have to apply the same procedure, but the numericals will be different. That is why this DSP is somewhat easier than circuits and controls. In controls also, there are many good concepts that will lead you to good results, but you have to understand that clearly and work it on. That one I am going to tell you. And in the circuits also, there are few quite things. So in the circuits, I am going to teach you how to handle that particular circuit subject, because those subjects are really important, right? Those subject is really important, and and that is for module 1 and 2. So I need to gain good marks. So that is why I'll tell you how to gain good marks in that subject with respect to circuits. Controls we just discussed, however, is in the syllabus, and we'll understand what is important and what is not. I'm making you understand each and every concepts in detail. So please do follow my videos from the beginning so that you get to know clearly, right? Yes. So now let's move on to problem without wasting the time. This is not a waste of time. I'm repeatedly telling you because you'll get to know things before what I can say starting with respect to this question. You need to know these things always, right? Yes. So now coming on to the, yeah. So now coming on to the question, what is my sequence? So my sequence is, just a minute, I'll just take a thickness, more of thickness, yes. So my question is that I have x1 of n is equal to, just a minute, I'll open the question. Yeah, x1 of n is equal to 2121. Just a minute, I'll open it. It is 2121. So here there is one thing, students, please do understand that without fail. So it is 2121. Yeah. So and my x2 of n is what? So my x2 of n is equal to, that is what I can say, yeah. Which one? That is 1, 2, 3, 4, right? So here there is an arrow mark given to you. So where is the arrow mark given to you? So my arrow mark here, it has been given over here, and for this my arrow mark is given over here. So what is my arrow mark denoting? So my arrow mark is denoting this that So I'll tell you what is my arrow mark is denoting. So my arrow mark is telling that x of 0 is that particular value. That's all. So what it is telling? It is telling that my x2 of 0, that is this, or I can say this x2 of 0 is that particular value, right? Let us start doing now with respect to that particular. So let me start doing that. So now you have a formula for circular convolution. So what is that formula? So you have a formula for the circular convolution, that is equal to your x3 of what I can say the m by x3 of m. So x3 of m is because you are going to find out the what I can say the 4-point circular convolution. So that is why it will become x3 of m. In the sense, he has only asked you to find out x3 of m. So x3 of m, which is equal to the circular convolution of x1 of m and x1 of n and x2 of n. Right? So now let me start doing that. So see here, just a minute students. So we are supposed to, what I can say, just take the this one, that is your formula. That is, what is your formula? Your summation of n is equal to 0 to 3. So why n is equal to 0 to 3? It's n is equal to 0 to n minus 1. But here for our convenience we are writing it as n is equal to 0 to 3. So now it is equal to what? It is equal to, that is x1 of n into x2 of what, into x2 of, that is what I can say here, m minus n to the power m minus n to the 4, m minus n of 4, right? M minus n of 4. So this is what is my formula with respect to the circular convolution formula, right? This is what is my circular convolution, and here this is what is my 4-point DFT sequence. So that's why I'm writing it as 4, and here it is x3 of m. So my m varies from what? My m varies from 0, 1, 2 and 3, right? So very first we are considering our m with respect to 0. So this is what is my formula for x3 of 0, right? Yes, my x3 of 0. So now what I can say, if I put what I can say the 0 in this above equation. So I have already substituted 0 in the above equation. So now what is that going to happen? Is that, before that I'll tell you. So first write this equation, and then the formula for circular convolution, and then what is supposed to do is, then you have to write substitute 0 in the given equation, right? To find x3 of 0 you have to substitute 0 in the equation. So substitute 0 in that particular equation. So if you substitute 0, what is your 0? Your m is equal to 0 here. Please to understand, your m is equal to 0. Why your m is equal to 0? Because we are substituting the values of m. Your n will remain constant. You are going to substitute the value of m, that is changing from 0, 1, 2, 3. So substitute 0 in this particular equation number 1. Let me take this as 1. So substitute 0 in 1. So we get it as what? We get it as x3 of 0. So which is equal to what? That is summation of what I can say, n is equal to 0 to what I can say 3, which is equal to what? My x1 of n into x2 of what I can say, my m is equal to 0. So what is 0 minus n? So that is minus n of 4, minus n of 4, right? So this is minus n of 4, and now we are going to draw the circular convolution with respect to the given. So just give me a minute. Yes. So now if I substitute the circular convolution, please do consider this much. So now if I consider the circular convolution, let me take a shape. So I need a circle shape, right? This is what is my circle, and yeah. So yes. So here you are going to make it bigger. Just a minute. Okay. So now here I have to bring this. So now I have to go to pen, right? I'll close this. So I'll just take this and I'll just move it over here. Yes. So now here this is what is my circle, and now what I need is that I need my x1 of n. So what is my x1 of n? My x1 of n, first I need to write it in anti-clockwise direction. That is, I'll start over here and I'll write it as, that is x1 of 0, that x1 of 0, and here what I can say, it is x1 of 1, And you're supposed to write it in anti-clockwise direction, students, right? You're supposed to write it in what? You're supposed to write it in anti-clockwise direction. That is your x1 of n. Your x1 of n should be very first written in anti-clockwise direction. So please do understand that. So this is what I can say, my x1 of 2. Okay, so this is what is my x1 of 3, and now what is supposed to do? So now what is supposed to, what I can say do is that, so here we are going to take this in anti-clockwise direction. This is what is my x1 of n. Now I will take another circle now once again. So I will take x2 of n in anti-clockwise direction now, right? I have a circle, so I'll just add a circle and I'll close it. Yes. So I'll make this still more bigger. So now here is what is my x2 of n. So x2 of n also I need to take it in anti-clockwise direction. So let me take it in my anti-clockwise direction. So just a minute, students. Yes. This is x2 of 1. I'm really sorry. X2 of 0. So here is what is my x2 of 1. And here is what is my x2 of 2. And here is what is my x2 of 3, right? So we are going to write it in anti-clockwise direction. So I wrote my x1 of n and x2 of n in my anti-clockwise direction. But what is that going to happen is that I have x2 of, this is x2 of minus n for me. It is not x2 of n, right? So very first I told you that I have to write my x1 of n in anti-clockwise direction. We wrote it. So I also wrote my x2 of n in anti-clockwise direction. But I don't have x2 of n. Here it is x1 of n, but I don't have my x2 of n. So what I have to do for that? So I have x2 of minus n. So I have to construct for x2 of minus n. I need not to construct for x2 of n, right? So for minus n, I have to circular fold it. So what is a circular folding? Your circular folding is you're going to circular fold the sequence x2 of n. That is this x2 of n you're going to consider and you're going to circularly fold it. So how do you fold it circularly? So how do you fold it circularly? In the sense you are going to what you are going to do? You are going to what I can say, that is shift this particular x2 of n in the clockwise direction. That is how do you shift it in clockwise direction? I'll just take another circle. Just a minute. Yes, and yes. So that is what I have to do now is that, just a minute, I'll push it up. Yes. So now what I have to do to get my x2 of what I can say minus n of 4. So I have to shift this x2 of n in anti-clockwise direction to clockwise direction, right? That is, yes, I have to plot the x2 of n in clockwise direction. That is, I get it as, this is what is my x2 of 0, right? Just a minute, students. Yes. I'm so sorry. Just a minute. X2 of 0 and here is what is my x2 of 1. So I have to write it in clockwise direction. Please to remember. So as I have x2 of minus n over here, x2 of minus n to a 4. So I have to write it as what? That is, I have to write it as that is equal to, you are going to plot this x2 of n in clockwise direction. Right? Yes, it is ulta. That is, so what is my circular folding? My circular folding here in the sense I have to write plot as x2 of n in clockwise direction. Right? Yes, that is what is my circular folding. So if you get it like this, you are going to do the circular folding, and circular folding is an important part. Right? I guess you understand till now. What did we do? What did we do is that till now. So I'll just bring it upward. So what did we do till now was that we had x1 of n and x2 of n sequence, and we have to do solve this using circular convolution method. As this is 4-point DFT sequence, I am planning to do all the problem with respect to 4-point DFT. So I am taking this problem. Okay, and here you can see that it is what I can say. You are going to take the formula of circular convolution, because you are going to find x3 of n, which is equal to circular convolution of two sequence, that is x1 of m and x1 of n and x2 of n. So now I'll take the formula circular convolution, that is x3 of m is equal to, that is my summation of n is equal to 0 to 3. Why n is equal to 0 to 3? Because it's my 4-point DFT and the summation of my 4-point DFT, whereas from n is equal to 0 to 3. So this is n is equal to 0 to 3, right? And here it is x1 of n into x2 of m minus n, that is what I can say, to the power m minus n of 4. What is 4? 4 is my 4-point DFT. So that is what is represented in m. So if you see with respect to the original circular convolution formula, so your formula will be what? That is, here instead of this n is equal to 0 to 3, you have a summation called as n is equal to 0 to n minus 1. That is what I told you. What I told you, it is n is equal to 0 to n minus 1, and here instead of 4 it would be n. This is what is my number of samples. I have 4 samples, so I am going to write it as 4, and here it is n is equal to 0 to n minus 1. So what is my capital N? It is 4. So therefore it is 4 minus 1, which is equal to 3. So therefore I get it as n is equal to 0 to 3. Right? Yes. So now here I have x3 of m. So I have to vary m is equal to 0, 1, 2, 3, and whatever I get x3 of m. So that is whatever I get x3 of 3. So that should be is equal to here what I can say, the x1 of n circular convolution. What is that I am trying to tell you is whatever you get x3 of 3, that should be a circular convolution of, that is x1 of n, x1 of n circular convolution of x2 of n. So that is what you have to get, right? So now here, so we are going to what I can say, just a minute, I'll just bring it down. So see, we are going to substitute 0 in 1. What is this? Here we are going to substitute 0, because we are taking m is equal to 0, 1, 2, 3, and we are checking for m is equal to 0, m is equal to 1, m is equal to 2, and m is equal to 3. So first I have to take m is equal to 0. So I took m is equal to 0 over here, and here also there was 1 m. You can see, right? I am showcasing you in the arrow. So this m is equal to 0 is substituted, and I got 0 minus m, which is equal to minus m. So now what happened for my x1 of n? So I have to, what I can say, the put it in anti-clockwise direction. That is, you are going to what I can say, sequence x of n, you are going to plot it across this particular circle in anti-clockwise direction. And now what are supposed to do? You are going to plot x2 of n, x2 of n, that is plotted across the circle in the anti-clockwise direction. So now what is that going to happen is, I haven't got x2 of n here. What I have got? I have got x2 of minus n. So I have got x2 of minus n. So for x2 of minus n, what I have to do? I have to plot x2 of n across the circle in clockwise direction. So that is what I did it over here. So what I can say, I plotted the x2 of n across the circle in clockwise direction. So I need to consider this and this now. This one is not required. I have to consider this one as well as this one. So now what I am supposed to do is, I am going to just write this now. I am going to just write this particular, just a minute, I am going to write this particular and this particular together. And in this x1 of n and in this x2 of minus n, so I will just write this as x2 of minus n. Just a minute, students. So this circle is x2 of minus n. So that is all to the power of 4, right? This is what is that. So now which one I have to write first? So I have to write this x1 of n circle at the first, and then I am going to write x2 of n at the last. That is, in the sense, I have to write x1 of n circle should be inside, and outside this x1 of n circle only your x2 of minus n of 4 should be outside, right? Yes. I'll just write that and showcase to you. Just a minute. Yes. So let me do that. So give me some time, students. Yes. How you have to do over here is, while writing, you can write it first x1 of n and then x2 of minus n outside x1 of n circle. But here I can't do it. So that is why what I'm going to do is, I'll take this one circle over here. Just a minute, I'll just make it still more bigger. You can do it according to me, or you can do it like that only. So I'll tell you that just a minute. So I'll take another circle and I'll place it over here. So yes, so now this is what is my yes. So now this is how I get. So okay. So now what I'm supposed to do is, so for you people, you can just write first x of n circle, and then outside that you can write x2 of minus n of 4 circle, right? But what is that going to happen is, I can't do that here. That is why I just did it like this, right? So this is also the same. So here this is what is my x1 of n circle, that is I'll write it in anti-clockwise direction. So see here, this is x1 of 0. So here this is what I can say, my x1 of 1. So that is why. Okay. So first you write x1 of n circle, then write x1 of minus n to the minus n of 4 circle, right? I am writing like this because I can't write it over here. That is why. Okay. So this is x2. I'm sorry, this x1 of 2. Yes. So please do try to understand things. I'm trying to make you understand things in a very simple manner, right? I'm trying to understand things in a very simple manner, and I'm going according to our syllabus. So this is what is very easy to understand. Why? Because if you take your 4-point DFT concept and if you learn all the problem with respect to 4-point DFT. So a 4-point DFT concept is only complete. You don't want to again go back to 4-point DFT and learn any other methodology, right? And then let's come to 8-point DFT. Let us see the 8-point DFT problem with respect to formula method, with respect to your DFT, that is this method, which one? That is your matrix method, with respect to the circular convolution, with respect to this DFT IDFT method, and IDFT of that particular by using the formula method. All those we'll see, and we would be clear with all the questions from 4-point DFT and all the questions from 8-point DFT. And you can also say that then you can go to any other point DFT which is in the textbook or which is given in the question paper. We can do that. And why I am taking 4-point and 8-point only is because those two will come for your exam for sure without fail. That is why I am telling you, you have to study those two without fail, and you have to learn the DFT properties of DFT concept. If you have less amount of time for your examinations, if you for example, if you suddenly don't have time to study for exam, you are unwell, or you have some issues in studying for exams during that period given by the V2 people, like they'll give you 3 days or 4 days before the exam, or after the lab only, they'll give some time, right? After the lab they'll give some time before you're starting of your first exam, right? So if you don't have that much sufficient time to study this, you have planned for this particular module is, you have to study very first concept, that is the frequency domain sampling and reconstruction. And then you have to study 4-point DFT and 8-point DFT, all the types of problems from 4-point and 8-point. That is your matrix method, your formula method, your DFT IDFT method, your circular convolution method, that is using concentric circle method, and your IDFT. You have to learn all these things without fail, what I am telling now. And then you have to go to properties of DFT. If you learn that much clearly, you will easily pass this model without fail. That is why I am also trying to tell you tips and tricks over here. That is why I am going according to your examination, so that you would be more confident on writing your exams, right? Yes. So now let me take this in clockwise direction. So just a minute, students. Yes. So here it is x1 of, and here it is x2 of 0. And here it is what I can say, my x2 of 1. So here it is x2 of 2. and here it is x2 of 3, right? This is what is, I can say, my circular convolution of what? This is x2 of minus n of 4, right? So now next thing what I'm supposed to do is that, so I have to, what I can say, now substitute the value. So you know what is x1 of 0, I'm sorry, just a minute. Yeah. You know what is x1 of 0, x1 of 1, x1 of 2 and x2 of 3, right? So let's substitute that. So my x1 of 0 is equal to what? So my x1 of 0 is equal to what I can say here. This one. Just a minute, I'll just showcase to you. So x1 of 0 is equal to what I can say 2, right? This is 2. I'll just write in another color. So it is 2. So this is 1. This is 2 and 1. Don't get confused where this 2 1 2 1 came. It is in the question. You can see the x of n sequence that is being given in the question, right? So for my x2 of n, so this is what is my x2 of 0, which is equal to what I can say my 1, right? 1 2 3 4 you are going to write. The arrow mark is given, but the arrow mark is of not that sense over here. That is why you are going to directly substitute 1 2 3 4, right? The arrow mark was for 2, but it was not of that sense. So that is why let me take my x of 0 is 1 and here it is 2 and here it is 3 and here it is 4. So now what you're supposed to do is, so you have to get your x3 of 0 resultant. So let me write it over here. You have to get x3 of 0. To get x3 of 0, what you're supposed to do now? You're going to multiply two sequences, right? So that is, you're supposed to, just a minute. That is, you're supposed to multiply this x1 of 0 into x2 of 0. So what is this x1 of 0 into x2 of 0? What is this x1 of 0? It is 2 and x2 of 0 it is equal to 1. So it is equal to 2, right? Now once again it is plus. So I have to multiply x1 of 1 into x2 of 3. That is what? My 1 into 4. What is my 1 into 4? It is equal to 4, right? Yes. So now I have to go in clockwise only, students. Why clockwise? Is because my x1 of n is in clockwise direction. So I have to go in clockwise direction and I have to multiply with the other sequence, that is other sequence that has been present in the outer circle, right? Yes. This I have to follow in clockwise direction only. So how I have to do is I have to take x1 of 0 into this x2 of 0 that is present in outer circle. Then I have to once again come in, I'm sorry, this anti-clockwise. I'm so sorry. Really sorry for the distraction. It's anti-clockwise. So I have to come back again in anti-clockwise direction and I have to take x1 of 1 and then I have to multiply with x2 of 3, right? Yes. So now it is once again I come in anti-clockwise direction and I see that there is x1 of 2 and if I come in the same direction here I get it as x2 of 2. So that is why what is my x1 of 2 into x2 of 2, that is 2 into 3, it is 6. So now once again it is plus. So when I come in anti-clockwise direction I get x1 of 3 and here it is x2 of 1. So I get it as this 1 into 2. What is 1 into 2? It is equal to 2, right? Yes. So now what is 2 plus 4 plus 6 plus 2? So 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 2 is 14. So I get it as 14. So what is my x3 of 0? I'm really sorry. My x3 of 0 is 14, right? I got x3 of 0 now. So now what I'm supposed to do is I have to take x1 of 1, right? Let me take x1 of 1. So for that I'll just shift all this to here. Just a minute, students. Yes. Okay. Oh my God. Just a minute, students. I'm sorry, there was some glitch. Okay, I'll just just a minute, students. There was some glitch over here, so I'll just clear the glitch. Wait a second. Okay, I'm so sorry. Wait a second. I just did things by mistake. I had to recorrect it. So wait a second. Oh God. Oh, what I have to do now? Just a minute, I'm getting it, students. Yes. Did I get it? Yes. Yes, students, I got it. So sorry for the distraction that happened. So I got all these things. So yeah. So now let's move on to the second one. So if I shift this over here, I'll take the second circle. So for second circle, let me discuss one thing. So here we are going to find x3 of 1. So to get x3 of 1, so what is supposed to do? What I'm supposed to do is that, so I have to take the same x1 of n. My x1 of n circle always remains the same. Please to understand, my x1 of n is in anti-clockwise direction. The same thing will remains the same. But what is that going to happen for x2 of n? x2 of n will change. So let me discuss that. So let me come to that. So for that I'll just push this downward. Okay. So actually, what's my formula? So my formula is that is x3 of 2 is equal to, I'm so sorry for this particular, yes. These are all really important questions. That is why I'm teaching you students. Please do understand things. So don't feel that this should be what I can say done after doing the circular convolution derivation. No, it is like as it is 4-point DFT question only. I'm doing it. So I'm doing all the important questions first from 4-point DFT so that you practice all these things without fail and you use your exams without fail, right? So x3 of 1, what is my formula? The same formula, that is n is equal to 0 to what I can say the n minus 1. N minus 1, what is n is equal to 0 to n minus 1. So which is equal to what I can say, that is the this one. Which one? Your x1 of n into, okay. So x1 of n into what? That is equal to your x2 of what I can say, that is m minus n. So what is m? Your m is 1. So it is 1 minus n of 4. Right? 1 minus n of 4. So what is this now? So this is something different. So for this what you have to do, for 1 minus n of 4, you are going to shift x of minus n circle. So that minus n circle what we got, that is what I can say, this circle what we got. So x of minus n, this circle what we got, we are going to shift it in what I can say the anti-clockwise this circle, that is this upper circle. Just a minute, I'll just bring it still down. This upper circle what we have got, we are going to shift it in anti-clockwise direction. Right? Actually, this is already in anti-clockwise direction. Now, this was in clockwise direction. That is x of minus n of 4. That was in clockwise direction, and I have to once again shift this x of minus n of 4 to anti-clockwise direction to get x of 1 minus n of 4. Right? So, that is why let me do that. So, before that, let me bring this down. Yes. Okay. So this is for an anti-clockwise direction, right? That's all you're supposed to do. That is, you can take 1 minus n as what? 1 minus n as minus n minus 1. As we learnt in basic signal processing, right? It will, in basic signal processing, what it will tell? It will tell that it is n minus 1 is equal to 0, n is equal to 1, and you have that minus. So that minus is telling you reflection. N is equal to 1 is what? N is equal to 1 is your what I can say shifting, and that minus is reflection, right? Yes. So this you are going to shift in anti-clockwise direction. So now let me take the same circle. What I'll do is I'll just copy this. Just a minute, I'll just bring it down. So I'll copy the whole thing. Just a minute. Yes. So I'll just copy. Now what I'm supposed to do is I'm going to just shift it and I'm going to paste it. So because the same circle I need, so I'll just make a paste. So I got this circle pasted. So let me now what I can say, get back to the other one. This circle, let me just copy and let me just paste it over here. Okay, I'm so sorry students. Let me just copy this circle. I'm so sorry. Wait for a minute. Okay. Yes. So now it is correct. So now here what I'm supposed to change is, here I'll erase all these things. I'm going to, what I can say, write it in a fresh manner. That I told you I need to put it in anti-clockwise direction. So this is what I can say, my, what I can say, x2 of 0, right? So this is what is my x2 of 0, and here you're going to what I can say, shift it in anti-clockwise direction. I guess you understood things. So how do you shift in anti-clockwise direction? That is, here it will be x2 of 1. Why x2 of 1? I'll just tell you that also in a clear manner. So I'll just come back to here. So this circle is what I can say, my, this circle. So this circle I am going to showcase to you. See, this circle is what I can say, my x2 of minus n of 4 circle. So here I have what I can say, my x2 of 0. If I shift this particular circle in anti-clockwise direction, I have to shift from the origin. My origin is x2 of 0. So I have to shift that x2 of 0, one shift in anti-clockwise direction. So if I shift this one shift in anti-clockwise direction, I get my x2 of 0 over here. And here it will get replaced by x2 of 1. And this will get replaced by x2 of 2. And once again here this will get replaced by x2 of 3, like that it goes on. So here origin is x2 of 0. So this x2 of 0 origin, you are going to shift it to shift it in anti-clockwise direction by one position. So as n is equal to 1, you are going to shift it by one position. And if you shift this by one position, you are going to get it as x2 of 3 over here. In place of x2 of 3, you are going to get it as x2 of 0. In place of x2 of 0, you are going to get it as x2 of 1. And in place of what I can say, the x2 of 1, you are going to get it as this x2 of 2. Here it will come. And this x2 of 2, in place of this, you get x2 of 3 over here. That is what it's going to happen. I guess you understand things clearly. And now, so let me write that. So this is what is my, what I can say, the x2 of 0. So here is my x2 of 2. This is the same process for all the problems, students, right? Yes, this is the same process for all the problems. Why? Because you can see the formula there. In that formula, you have to substitute for m is equal to 0, 1, 2, 3. And if you substitute for m is equal to 0, 1, 2, 3, you get it as minus n, 1 minus n, and what I can say, the 2 minus n and 3 minus n. That's all you get. For 8-point DFT, it might what I can say, vary. That is, you get 4, 5, 6, 7 and all, because as it is an 8-point DFT, you will get it from 0 to 7, right? That is why you have to substitute your m values from 0 to 7. That it will extend. It will not vary. It will extend. Right? After 3 also it will extend. That is what one thing. But the same formula, but your values will change. That's all. That is why I am telling you, please to understand this particular. Okay. So see here, this is, I get it as what I can say, the 1. So this is what is my 2. And here is 3 and 4, right? Yes. So now what I have to do, I told you that I have to multiply this 2, I have to multiply these 2, and I have to multiply these 2 and add together, right? Yes. So my x3 of 1 will become equal to, so this is equal to what I can say, that is your x2 of 1. This and this is 2 into 2, which is equal to 4. x2 of 0 and x1 of 0 into x2 of 1, 2 into 2, which is 4. Plus what I can say, that is equal to 1. So what is 1? You are going to get it as, that is your 1 plus 1. So 1 plus 1, which is equal to what I can say, it is 2. And then here it is what I can say, this 1 into 1 is 1. I'm so sorry, really sorry for the distraction. It is 1 into 1, which is equal to 1. So you are going in anti-clockwise direction only. You are going according to this circle only, and you are going to multiply with the other term whatever is present outside the circle, right? Yes, and here it is 2 into 4 which is equal to 8. So let me write it as 8, and here it is what I can say, that is here 1 into 3 which is equal to 3, right? Yes. And yes, and now if you add this, you're going to get it as 4 plus 1 is 5, 5 plus 8. 8 plus 5 is what? 8, 9, 10, 11, 12, 13. 13 and 13 plus 3 is 15, right? Yes. So you get it as 15. This is what is, you get it as 15. In the last one, you got it as what I can say, not 15, it is 16. Just a minute, I'll just take it once. I'm so sorry for the distraction. So 5. Yeah, it is 16, correct. It is 16, not 15. So 4 plus 1 is what? 5. 5 plus 8 is what? 5 plus 8 is 13. And here this is 5. This is 13 and this is 13 plus 3 is 16, right? Yes. So I get it as 16 as my resultant. There you got it as 14 and here you got it as 16. And now if you take what I can say, x3 of 2. So for x3 of 2, I am going to get all the things as same. Just a minute, I'm so sorry. Just a minute. Yeah. So xt of 2 which is equal to this, all things are same. That is summation of n is equal to 0 to 3. What I can say, it is equal to your x1 of n into what I can say, you get it as, that is x2 of 2 minus n of 4, right? 2 minus n of 4 in the sense whatever 1 minus n you have got, that is this outer circle whatever you have got, this whole outer circle whatever you have got, you are going to what I can say, shift it one position in anti-clockwise direction, right? Just a minute, I'll just move friend. Yeah, you're going to shift it in anti-clockwise direction, right? This whole circle you're going to shift it in anti-clockwise direction. To shift it in anti-clockwise direction, once again I have to take my origin, that is x2 of 0, and that only I'm going to shift it to one position over here. I get it x2 of 0 over here, and this x2 of 0 is replaced by x2 of 1, and this x2 of 1 is replaced by x2 of 2, and this x2 of 2 is replaced by x2 of 3. That is what it's going to happen, and I'm going to erase this part. Just a minute. Just a minute, students. I'm so sorry, there is some issue happened. Wait. Just a minute, students. Wait a second. I'm so sorry. So now let me just a minute. Let me erase this. So I'm so sorry for the distraction that happened now. So yes, I guess you understood, right? Yes. So now let us move on to this particular. So we are going to shift it. How do you have to shift it? I told you, right? That is what you have to solve the procedure. So what I'm supposed to do is, so I'll just take another circle. So just a minute, students. Wait for a second. Yes. I don't copy this because it's somewhat distracting to me. Okay. Yes. So now it's correct. So now what we are supposed to do is, I'll just increase this one so that it will be good. Just a minute. I'll just do that. Yes. So here it is. What I can say, the same thing, students. That is your x1 of 0, x1 of 1, okay, right? So this is what I get, and now I have to, where I have to write my x1 of 0? Here. So my x2 of 0, I'm sorry, my x2 of 0 I have to write it over here, and then here I have to write my x2 of 1. Just a minute students, I'll just write it and tell you. Wait a second. So as it is an anti-clockwise direction, so it would come over here, right? Yes. So it would come over here, right? I just told you how. Yes, yes. It would come over here because I'm going in anti-clockwise direction, not clockwise. My clockwise is like this, students. Anti-clockwise is like this. That's all. I guess you know what is how clockwise direction and anti-clockwise direction, right? Yes. So it is x2 of 2. You are going to shift all the things in what I can say the anti-clockwise direction here. Yes. You got it? Yes. Just a minute. Okay. So this is what is the diagram, students, and now I'll write the value. So this is 2121, right? This is 2121. And what I can say, just a minute, I'll just check it once and before. Oh yeah, okay. Okay, and here it is what is my this one, which one? It is 1 2 3 4. So here is 1, and here is 2, and here is 3, and here is 4, right? Yes. So you got it. Now you have to multiply this with this, this with this with this, and this with this, and that. So now if I multiply this with this, I get it as 2 3s are 6. So let me write x3 of 2 is equal to what I can say, my 2 3s are 6 plus what? It is 6 plus it is equal to, wait a second. It is plus what I can say, my, which one? That is, this is 2 into 1 is 2, and here it is 2 into 1 is 2, and here it is 1 into 4 is 4. So what I get? So I get it as, what I can say, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 4 is 14. So I get it as x3 of 2 is 14. Just a minute. Yes, I got it as what? So I got it as 14, right? Yes. So now here I'll just take one more thing over here, that is x3 of 3. For x3 of 3 I need to substitute m is equal to 3. So if I substitute m is equal to 3, let me do that also fast. So it is n is equal to 0 to 3, which is equal to what I can say, that is x1 of, I'm so sorry. X1 of n into what I can say, the x2 of 3 minus n of 4, right? Okay, so for this you are going to shift it 2 minus n of 4. This is 2 minus n of 4, the outer circle. The inner circle is always what I can say, the x of n. Here it is 2 minus n of 4. That is, you are going to shift it what I can say in the anti-clockwise direction. So for that I have to once again take my what? That is, once again take my what I can say, the initial value, that is x2 of 0. That I am going to take and I am going to shift it. So this x2 of 0 will come here now, and this x2 of 1 will come here now, this x2 of 2 will come here now, and this x3 of 2 will come here now, right? So I'll take another circle and showcase to you for this one. So now let me write. So this is what is my, what I can say, the x1 of 0. I'll just write it. So sorry. So this is what is my x1 of 1. So this is what is all the same, students, but you are going to have some small changes, that's all. So that is why I told you, please to try to learn easily, right? Try to learn in an easier manner. Don't go in a complex manner. Don't try to learn all the type of DFT one method, right? What I'm trying to tell is, if you take a formula method, don't try to learn 4-point DFT also there and 8-point DFT also there and any other point DFT using formula method. No, you have to take first one, you have to take 1-point DFT. That is 1 point in the sense which point? That is 4 point you have to take first, and you are going to start studying all the methodologies that comes under 4-point DFT. To solve 4-point DFT using all the methods, whatever you get, you have to learn. Then come to 8-point DFT. If you learn like that, it will be easier, or else you might get confused. Right, you have to deal with that particular point DFT and then work on completely with that particular point DFT until and unless you finish that, you should not go to another point DFT. That is what I am trying to tell you, and that is how I am going to do, because you will get confused, right? If you do 8-point DFT, it might be different. The process might be different in 8-point DFT. So you might get confused between 8-point and 4-point. So first completely try to learn the 4-point DFT using formula method, using DFT ADFT method, using concentric circle method, that is circular convolution, which we are doing now, and this one, which one it is, your matrix method. You have to learn all this without fail, and then come back to, and IDFT also, IDFT, inverse discrete Fourier transform also, and then come to this 8-point DFT, so that you will be more clear, right? Yes. Yeah, so now here it is what I can say, my x1 of here it is what I can say, my, here I'll write it as x2 of 0, and here it is x2 of 2, so now this is what is that, and now see here, students, so here this is, I've already told you, this is 2 1 2 1, it is being given already, and here it is 1 2 3 4, so this is 1, no, here it is 1 2, just a minute. You have to write like this only, students. How to represent in your exam, I'll tell you in the last stage. Okay, so this is 2 and this is 3 and this is 4, right? Yes. Now, okay, so now what you're supposed to do is that, so you have to now once again do the same, multiply this with this with this with this and this with this, right? Yes. And then what you're supposed to do is that, which is equal to your x3 of 3, which is equal to what I can say here, 2 into 4 is 8. So it is what I can say, 2 4s are 8 plus what I can say, this is 1 3s are 3, and it is plus what I can say, 2 2s are 4, and once again it is plus what I can say, 1 into 1s are 1, right? Yes. So now here you get it as 8 plus 3 is what? 11, and 11 plus 4 is 15, and 15 plus 1 is 16, right? So what is the resultant that you got? The resultant that you got is 14 16 14 16. Did you get? Yes, it is 14 16 and 14 16, right? And this question was asked for my exams also, so please do practice it without fail. So what you have to do is, if you try to refer our question paper 17 EC 52, so you can refer module 1, module 2, right? Module 1, module 2, and some part module 3 also you can refer without fail. Module 4 and 5 you have to look at once, right? Module 4 and 5 you have to look at once, and in module 4 and 5 there are some selected topics wherein you can study, and some of the topics which you can't study. That I'll tell you if you are trying to study that also without fail. So this question was asked for my examinations, and please do try to study this without fail. This is really important. It's been given for my exams. I've written this, so I'm telling you, right? So please do study this. So this is what is my x3 of n, right? And you're going to write just a minute, yeah. So this is what is my x3 of n. Now we understood how to do circular convolution. Yes, circular convolution is really easy. So tell you once again. So this is what is my x3 of n, and here is my arrow mark, right? So let me go back once again. I'll just go back to and showcase you all the things. So now what is the given question? My given question is x1 of n is equal to 2 1 2 1 and x2 of n is equal to 1 2 3 4. So now what I have to find out? I have to find out x3 of n, wherein it is a circular convolution of x1 of n and x2 of n, right? Yes. So now here my formula is x3 of n is equal to, that is summation of n minus 1 to n is equal to 0, x1 of n into x2 of m minus n of m minus n of n. So that is what is their original formula. But what happened was my n was 4. So what I did, I substituted n here 4. So I got 4 minus 1, which is equal to 3. That 3 which I have written it over here. And here this n I have replaced it by 4. Right? Yes. And now so coming on to the next one. So you have to substitute your n values as 0, 1, 2, 3. So now let us substitute m is equal to what I can say, the 0 in 1. So I'll tell you one trick over here. M is equal to 0 in 1. So you get xt of 0 is equal to the summation of 3 to n is equal to 0. That is x1 of n into x2 of, that is minus n of 4. Right? So this one equation, this is equation number, what I can say, let me take it as 2. And just a minute. If you substitute m is equal to 2. So you are going to get it as this resultant equation, which is what is my equation number 3. Just a minute, I am trying to tell you something. Wait, students. Yes, and now here it is this equation, that is this particular thing. I am so sorry. Yes, yes. This particular thing is what is my equation number 4. And this particular thing is what is my equation number 5, right? Yes. So now what I told, my equation number 2, 3, 4 and 5. I'll get back to you. Equation number 2, 3, 4 and 5 is the same for all the problems. My trick is what? Equation number 2, 3, 4 and 5 is same for all the equations, right? Yes, just a minute. Yeah, equation number 2, 3, 4 and 5 same for all the equation. This is what is equation number 2 and this is what is my equation number 3, right? It is same for all the equations. What you have to do is, you have to just by heart this equation. What equation? By heart the, what I can say, the particular this one. This particular equation you have to by heart it without fail. That is, here in place of 3 would just write it as n minus 1, right? In place of 3, I'm sorry, wait a second students, please to wait. I'll tell you the tips and tricks to easily solve this without fail, right? This is n minus 1 you can write, and here you try to write it as n. So according to your value of n, that is here it is 4, you substitute it as 4, or else if it is 8, you substitute it as 8. Now I am telling for 4-point DFT, please to understand, right? Yes, this is n, right? Yes. So now if you try to learn this equation is equation number 1. If you try to learn this equation without fail, so you can do solve easily. So for this equation, what you have to do is first learn this equation. First by heart this equation. I'll teach you how you get this equation in the derivation part. It is not for now. Okay? Yes. So now please do try to learn this equation. After learning this equation, you have to remember only two things in this equation. That is, one is you have to substitute the value of capital N. Your capital N is what? Number of samples. You have 4 samples, that is it is 4-point DFT, right? Yes. So for this question, I am not telling, for the other question it might vary, right? This is number of sample. You need to know that after by hearting this equation, after writing this equation in your examination, so you are going to write, how to write in examination. First you are going to write the given sequence is x1 of n is equal to this and x2 of n is equal to this. First you are going to write what? The given sequence is this x1 of n is this and x2 of n is this, right? And then now next what you're supposed to write is, so you're going to now, just a minute, I'll just close this. Yes. Now after writing that, you're going to write it as the equation for, just a minute, I'm so sorry, just a minute. So we are going to write the equation for circular convolution as, see, I'm going to write it is circular convolution. I guess you understand, right? Yes. So you're going to write the equation for circular convolution is, and I have to write, and then you have to write this particular equation. That is step number 2. Step number 1 is you're going to write the given sequence, and then you're going to write this particular. This is step number 2 you're going to write. After you're going to write this, you need to remember only one thing. While practicing, you need to remember one thing. What is there to remember is, here you are going to substitute n, that is number of samples. And the second thing what you are going to substitute is, you are going to substitute m is equal to 0, 1, 2, 3. And you are going to solve for that. First you have to substitute 0 and get the resultant. Then you have to substitute 1 and get the resultant. Then you have to substitute 2 and then you have to substitute 3 and get the resultant. So that much you have to remember. And then next thing what you are supposed to do is that, so you have to substitute 0 in equation 1, and when you substitute 0 you are going to get this particular equation. That is what? Xt of 0 is equal to summation of n is equal to 0 to 3, that is x1 of n into x2 of minus n of 4, right? This equation is same for all 4-point DFTs. This equation, that is your 2, 3, 4 and 5. The equation number 2, equation number 3, equation number 4 and equation number 5 is same for all the 4-point DFTs. Your number will vary, that's all. What varies? Your question will vary. Which question? That is this x1 of n. These two samples will vary, but not this equation and this equation number 2, 3, 4 and 5. It will be the same. So try to by heart this equation and try to understand that you have to substitute a value of n, that is 4 over here, as this is 4-point DFT, and try to understand that you have to substitute only values of m over here and get the equation. So that too, if you understand, then you can easily do this. And these equations are same for the 4-point DFT. For 8-point DFT, it will what I can say x10, but for 4-point DFT this 2, 3, 4, 5 is same for all the 4-point DFTs without fail. For all the 4-point DFTs you get it like this, but here sequence x1 of n and x2 of n varies, that's all. So this one I already explained you how it is. So this is circular folding you have to do because it is x2 of minus n of 4. So we have done circular folding over here. I guess you understand, right? Yes. This is what I can say. I'll erase this. A minute. Right now, so now next thing what you have to do is you are going to take x3 of 0. So here you need to learn one trick. What is that? You are going to write your x1 of n circle first. First here x1 of n circle first, and then next thing what you're supposed to do is outside that, outside you're going to write x2 of n, right? That is, you can directly tell it as is equal to, you're going to write x1 of n is plotted as an inner circle and your outer circle is x2 of n, right? So inner circle is what? Your x1 of n, outer circle is x2 of n. Right, these things if you know, you can easily crack it. That is why I'm telling you each and everything clearly, right? I just explained it to you in detail. Now I'm telling it to you in a clear manner, right? Yes, this is x2 of n is outside circle, x1 of n is inner circle. See, this circle is x1 of n and this outer circle is x2 of n. So now how to find this x1 of what I can say, that is your x1 of n, that is equal to x3 of 0 and x3 of 1 and all. How to find out is you are going to multiply this 2, this 2, this 2 as well as this 2 you are going to multiply, as well as this 2 you are going to multiply and add it together. That is, this 2 will result in 2 and this 2 multiplication will result in 4. This 2 multiplication is 6 and this 2 multiplication is 2, wherein you are going to get 14. So for you have to remember, you will get only 4 things. That is, one is x of just a minute, I'll tell you. I told you, no, 2, 3, 4 and 5 question is the same for all 4-point DFT. So therefore that is why I am telling you, right? So you will get only this thing in 4-point DFT. That is, one is this one and one is this, what I can say, 1 minus n to the power of 4, and here we will get 2 the same thing and 3 the same thing, right? Yes. So now for all these things, for this it is clockwise. For this it is clockwise direction. For this it is clockwise direction, and for all others, so for this one, for this one, for this one it is anti-clockwise direction, right? Yes. Yes. For all others it is anti-clockwise. You need to remember, for these three it is anti-clockwise direction. That is what anti-clockwise direction is. For this one you are going to shift this x of n of 4. This particular in your anti-clockwise direction, and for second one you are going to shift this x of 1 minus n of 4 in anti-clockwise direction, and for third one you are going to shift it to that is x of 2 minus n of 4 in anti-clockwise direction. That's all you need to understand. This thing you need to understand. This is what is the third thing you need to understand. And now here you are going to, if you understand all these things, you can easily do the problems without fail, right? And now coming on to this one also you have to understand. I told you now what you have to do. You are going to multiply these two and you are going to add and get the resultant. This much if you understand, it is really easier. What you have to understand? You have to understand that the equation number 2, 3, 4 and 5, what I told you, is the same for all 4-point DFT, and you need to learn this equation without fail. This equation is the major thing you need to learn first without fail, and then you need to understand two things here. That is, you are going to substitute the values of n there. N values, whatever, how much amount of sample you get, that you are going to substitute, and here you are going to substitute m is equal to 0, 1, 2, 3. That one you need to understand. And then what you need to understand is that you need to understand that your 2, 3, 4, 5 equation is same for all 4-point DFT, and in that you get these 4 things. That is, x of minus n of 4, x of 1 minus n of 4, x of 2 minus n of 4, and x of 3 minus n of 4 you get. And x of minus n of 4 you are going to shift it in clockwise direction, and all others you are going to shift it in anti-clockwise direction. That is, x of minus n of 4 is shifted in 1 times in anti-clockwise direction for x of 1 minus n of 4, for x of 2 minus n of 4, that is this one, for x of, just a minute, for x of this 2 minus, where is that? Huh. For this x of 2 minus n of 4, here x of minus n of 4 is shifted 2 times in anti-clockwise direction, and for x of 3 minus n of 4, here what I can say, x of n of 4 is shifted, what I can say, 3 times in anti-clockwise direction. And here you have to understand one more thing, that is you are going to write x of n, x1 of n is the inner circle and x2 of n is the outer circle. And after you shifting clockwise and anti-clockwise directions respectively, so you are going to, what I can say, add, what I can say, the multiply these two and add together and get the result. And this much thing if you understand, you can easily crack this without fail, right? This basic understanding is really important for you, right? And this is what is for today's lecture, and please do try to like, share and subscribe, and please do watch my videos. If you really like, please do share it for others. I am going to make the concepts easier. I am not going in what I can say, not much in detail. I am going to tell you whatever is required for in a neat and clean manner, because if you understand that much, you can easily write for your exams, right? Knowledge gaining is secondary, but you need to first understand the basic thing what to require for exam. If you try to go with knowledge gaining over here, and if you learn more and more things, you get confused. So first see through what is the question that's being given for you in the exam. Please try to understand that question, and please try to know how to write the answer for this. That particular thing you have to understand more in depth, not any extra thing, right? Yes, and this is what is for today's session, and thank you.